My dear students, let us further move on to some other problems from this current exercise, that is exercise 5.3. So let us do from page number 169, page 169, question number 9. So I would like you to please write down the question from the textbook, and we'll start solving that particular question number 9. So first and foremost, here in such kind of questions we have to do some substitutions. Okay, so first and foremost, write down given y is equal to sine inverse 2x by 1 plus x squared. This is the given. Mark it as equation number 1. We cannot simply do differentiating on both sides here. We have to do some substitution based on some trigonometric formulas. You will understand as I do this sum. Write down like this. We put x equal to tan theta. In place of x in this given equation, you put it as tan theta. Now why we are putting it? Because we have to reduce this particular trigonometric function, inverse trigonometric function, into some simplest form. So if x is tan theta, so we can write theta equal to tan inverse x. So this can be put as equation number, say this can be put as equation number 2, this can be put as equation number 3, as per your convenience. So therefore equation 1 implies, you can write equation number 1 as y is equal to sine inverse. In place of x you can put tan theta, so 2 tan theta by 1 plus tan square theta. So this is coming, my dear students. Now I'll take you back to your earlier classes. I think in chapter 2 you might have already learned about the sine 2 theta formula. Sine 2 theta formula is 2 tan theta by 1 plus tan square theta. So this formula is very essential. You can simply substitute this bracket value, what is inside the bracket, you can substitute it as sine 2 theta here, if you know this basic formula. So you can write it as sine inverse sine 2 theta here. Now sine inverse sine cancels, so you get 2 theta here. So my dear students, you get y is equal to 2 theta, and this can be written as equation number 4 if you want. Otherwise you can just ignore this. I'll just use the eraser here. Yeah. So my dear students, I can write it as y is equal to, in place of theta, we know theta is tan inverse x from equation number 3. So you can write it as tan inverse x. Now my dear students, whatever complex function was there in equation number 1, that has been reduced to a simpler function. So now we can differentiate both sides like we were doing in the initial sums, question number 1 to 5, or say 1 to 8, how we were doing. We can make it simplify now, and it's already simplified. We can differentiate both sides of this equation 4 with respect to x. So let us do that now. You can pause the video and note it down. So my dear students, what we will get here is, we will differentiate both sides. Differentiating both sides of equation 4 with respect to x. So we will be getting dy by dx is equal to d by dx of 2 tan inverse x. 2 is a constant, bring out 2 d by dx of tan inverse x. So my dear students, this d by dx of tan inverse x, you should remember the formula. The formula is 1 by 1 plus x square. So you will get dy by dx is equal to 2 times 2 divided by 1 plus x square. So this will be your solution for this sum. So kindly pause the video and note it down. Next up, my dear students, we will be doing question number 11. Let me just copy that question number 11 from your textbook. First and foremost, I'm going to write here given. Given here it says y is equal to cos inverse 1 minus x square by 1 plus x square. That is what given. And then the value of x lies between 0 to 1. The value of x lies between 0 to 1. First of all, mark it as equation number 1, all of you. Okay, so let us start solving this. First of all, we have to again convert this into simplest trigonometric function form. So let x equal to tan theta. Let x equal to tan theta we can write. So theta will be tan inverse x. Say this is 2, this is 3. Now equation 1 implies we can write y is equal to cos inverse 1 minus tan square theta. In place of x I am putting tan theta, 1 plus tan square theta. My dear students, the whatever term is there in the bracket, this has a formula. Okay, so cos 2 theta formula you can note it down in the right side of your notebook. Cot 2 theta formula is 1 minus tan square theta by 1 plus tan square theta. You can note it down in the rough or in the right side. You should know all these formulas. You can write it as cos inverse. The bracket term will be reduced to cos 2 theta. Now my dear students, cos theta and cos inverse gets cancelled, so you get y is equal to 2 theta. So the theta can be replaced with tan inverse x, as you can see from equation number 3. So this one you can write it as equation number 4. Pause the video to note it down, all of you. Now I shall use my eraser and I'll just rub this, and then let me move on to the last part of this question. Now what we will do, just like the other sum which I did, we have to differentiate both sides now. Differentiating both sides of equation 4 with respect to x. Now it has become simpler for us, so we can do dy by dx is equal to d by dx of 2 tan inverse x. My dear students, 2 is a constant, so 2 can be brought outside. Tan inverse x का differentiation करना पड़ेगा. We know from the previous sum that the differentiation of tan inverse x is 1 by 1 plus x square. So this comes out 2 by 1 plus x square. So my dear students, this is the value of dy by dx. I hope you have understood this sum. Keep watching the video and do subscribe to my channel, and please do like the video if you understood it, and comment your feedback. It will be of much help. Thank you so much, all of you. Have a nice day.